All right, students, you've heard the notes, got a technical explanation of the formula for Boyle's law and the kind of graph it produces, but now it's time to actually solve a problem. So I'm going to take my trusty Sharpie and we're going to go to the whiteboard. So let's use my data projector. We're going to figure out how to solve these problems right now because I'm going to show you how to do them in real time. Okay, so here we go. Our formula says that we're going to have P1 equals V1. So I'm going to go ahead and just write that out. P1 equals V1. Or rather, P1V1 equals P2V2. Now, what does this actually mean? Well, it means that we're going to take the pressure multiplied by the volume at some time, the first time we measure it, and the pressure times the volume the first time we measure it is going to equal the pressure times the volume when we measure it some time later, the second time we measure it. That's all it means. It's a constant. So let's say we've got a, I don't know, a balloon, right? And we're going to say that this balloon has a pressure of 4 atmospheres. We'll start by using the unit of the atmosphere. We're going to say that the volume of this balloon is 2 liters. And that's before. And then we're going to say that later that the volume of the balloon decreases. It becomes just 1 liter. And so the question is, what is the new pressure? P2 is unknown. So this would be like you take a balloon that's a certain size, and then you would like squeeze it from the side. And when you squeeze it from the side, you would actually make the volume bigger, or sorry, you'd make the volume smaller, right? If you squeeze it, you're reducing its volume. And the question is, what happens to the pressure? Okay, so we're going to take our variables and we're going to write them out by plugging them into the equation. When we do that, since we're doing multiplication, if we actually have a number in a unit, we're going to put the number in the unit inside parentheses. So we have P1, P1 is the first thing given, so we're going to write 4 atmospheres. And then right next to it, we have V1, and that's given, we have 2 liters, so we put that in its own separate parentheses. And then, P2 is an unknown, so we just write P2. And then V2 is known, so we put that in parentheses, just like that. And what we want to do is we want to solve it so that we have just P2 over here. We want to solve for P2, right? Because P2 is the unknown, that's the whole point. So we want to get rid of that 1 liter, so we're going to divide this whole expression by 1 liter, which will cause that to cancel out. Of course, whatever we do to one side, we have to also do to the other. So we'll put 1 liter over here. Now, obviously, the 1 liters will completely cancel out on the right-hand side. But less obviously on the left-hand side, just the unit of the liter will cancel. And so this is going to become 4 atmospheres times 2 divided by 1. And I'm pretty sure you can do that in your head. 4 atmospheres times 2, yes, the answer is 8 atmospheres because that is the number and the units that were not canceled. Pretty straightforward. Pretty straightforward. So now let's go ahead and keep the same basic setup, and we'll do a different problem. This time we'll solve for an unknown volume. Okay. Formula doesn't change. And you know what? I think we'll continue to use balloons, but we will change some units. This time we're going to say that we have a pressure in atmospheres, and we're going to say that our pressure in atmospheres is actually not in atmospheres. We'll say it's in millimeters of mercury, and I'll go 600 millimeters of mercury. And the volume of the balloon will be 3 liters. And then at some unknown time in the future, the pressure in the balloon will increase. It'll be 1,800 millimeters of mercury. And, well, the volume is unknown. The question is, what will the volume be? Okay, so that's what we do. We always write out our variables. All these problems will always have 3 variables given. You write them out, and then we're solving for the 4th variable, whatever it is, wherever it is. Okay, so P1 is 600 millimeters of mercury. And we multiply that times 3 liters. So that's our left-hand side. And then P2 is given, it's 1800 millimeters of mercury times an unknown V2. Now again, we want to solve for V2, so we want to get rid of everything that's there. So to do that, we're going to divide this side by 1800 millimeters of mercury. But of course, whatever we do on the one side, we have to do the other as well. So of course, these two things completely cancel out. And less obviously, the millimeters of mercury cancel out. We have something cute here. 600 times 3 on the top is 1800 liters. And here on the bottom, we've got 1800, right? So 1800 divided by 1800, that's right, the whole thing's just going to be equal to 1. 1 watt? The answer is 1 liter, because that's the unit that wasn't canceled. So we had an unknown pressure before, we had an unknown volume. Now what we're going to do is, instead of looking at things that come after, we're going to have a variable problem where we know what happened afterwards, but we don't know how it got started. I mean, it's the same math. It doesn't actually matter if you're solving for what came before or what comes afterwards. So this time we're going to solve for what came before. Okay. And I'm going to use a different unit for pressure. I'm going to use the Pascal. I'm going to say that afterwards, that when we get done, we're going to have a pressure that's equal to 200,000 pascals. And well, what's the size of this thing? We're going to say it's 400 milliliters. Instead of liters, it'll be milliliters. Now, we don't know what the pressure is when we got started. That's our unknown, but we're going to say that we know precisely that the volume of the balloon was 1,000 milliliters back in the day when we got started. Okay, so again, we always write out our 3 known variables with the number in the unit, and we put a question mark by the unknown, and now we plug it into our equation. We're solving for P1, so we just write P1, and then next to it, the number and the unit for V1 is given, so we put that in parentheses right next to it. And then we're going to go over here. P2 is 200,000 pascals, and V2 right next to it is 400 milliliters. Now our unknown is over here, it's P1. We want to solve for P1, so we want to eliminate anything that's next to it. So that's 1,000 milliliters. And we'll do that. And of course, whatever we do to one side, we have to do the other side. This, of course, completely cancels. Here, we just cancel the unit of the milliliters now. Now, this is a little tricky, so just remember, this is 200,000, that's 400. Well, 200,000 divided by 1,000 is just going to be 200. So really, this is just 200 times 400. So when we get done doing the math, what do we discover? We discover it's 80,000. 200 times 400, 80,000 watt. The answer is pascals, because that's the unit and the substance that wasn't canceled. All right, so that's an example of how to do the Boyle's law problems. They're all multiplication. They're all set up like this, and we use cancellation of terms to figure out the value of our unknown. And I hope that was helpful.